Hello everyone, greetings from Hexar.in. I am Shubham Kumar Singh, your mentor in this workshop series. If you have any questions about the presented topic or our program, please feel free to reach out by mailing us at hexart@li2.in, Hexart, hexart@li2.in. In this session, we will continue our learning about Python, and this session will be more focused towards working with data in Python, and more specifically using lists in Python, because lists are the most common type of data structures used in Python. Now let's start with them. So before we jump straight into lists, dictionaries or any other data types, let's start with what is data. Now working with a single data value in Python works just like you expect it to. Assign a value to a variable and you are all set, just like this. Now if we print the value of a, it's showing us the value of 47 because we assigned it to a value of 47. Now here we don't need to specify that this is an integer, and if you were to check it, there is a built-in function called type, and if you pass a here, it will show you that it is of class integer. But we didn't explicitly tell it to be of an integer value. Now when we assigned an integer to the variable, the interpreter took care of the rest of the details and it defined it to be an integer. Now please note that not all programming languages work this way. So a variable takes on the type of value assigned. Now what are strings? Now if you assign a string to a variable, the same thing happens. The interpreter takes care of the details, and we don't need to declare ahead of time that the variable in this example is going to contain a string. So we can in theory practically assign any variable to any type of data type. So here if we are reassigning variable a with this string hexart, now if you print a, this will show you hexart. This ability to dynamically assign a value to a variable is central to Python's notion of variable and type. In fact, things are more general than this, and in that you can assign anything to a Python variable. Now everything is an object in Python, and any object can be assigned to a variable. In Python everything is an object. This means that numbers, strings, functions, modules, everything is an object. A direct consequence of this is that all objects can be assigned to variables. Any object can be dynamically assigned to any variable in Python. This begs another question: what is an object in Python? Answer: everything. All data values in Python are objects, even though on the face of things hexart is a string and 47 is a number. To Python programmers, hexart is a string object and 47 is a number object. Like in other programming languages, objects can have state, or also called as attributes or values, and behaviors, also called methods. So we can say, or you might think that Python is an object oriented language. Yeah, sort of. You can certainly program Python in an object oriented way using classes, objects, instances, and so on, but you don't have to. In the last chapter, none of our programs needed classes, and even in this session also we won't need classes. Unlike some other programming languages, you don't need to start with a class to create a code in Python. You just write the code you need. Now having said all that, everything in Python behaves as if it is an object derived from some class. In this way, you can think Python as being more of an object based language as opposed to a purely object oriented language, which means object oriented programming is optional in Python. But what does all of this actually means? As everything is an object in Python, anything can be assigned to any variable, and variables can be assigned to anything regardless of what the thing is: a number, string, a function, a widget, any object. There's really not a lot more to storing single data values in variables. So let's take a look at Python's built-in support for storing collections values. Now there are 4 built-in data structures. Now when we say built-in data structures, we mean that All of them are available to your code and you don't have to import them prior to use. Each of the data structures is part of the language. Now Python has 4 built-in data structures and they are lists, tuples, dictionary and set. Now take this for an example. Now is equal to now if we run this code, pay attention here. This first one, example A, in which we have written 1, 2, 3. This is an example of type list. B is an example of type dictionary. C is an example of type tuple, and D is an example of type set. Now what are these? Lists. Python's data structures are divided into two categories, ordered and unordered, and then they are divided further into two categories as mutable and immutable. But before we dive into all of that, let me explain what all these 4 data types are. Number 1, lists. Lists are an ordered mutable collection of objects. A list in Python is very similar to the notion of an array in other programming languages, in that you can think of a list as being indexed collection of related objects with each slot in the list numbered from 0 upward. Unlike arrays in lot of other programming languages though, lists are dynamic in Python, which means they can grow and shrink on demand. There is no need to pre-declare the size of a list prior to using it to store any objects. Lists are also heterogeneous, in that you do not need to pre-declare the type of object you are storing, and you can mix and match object of different types in one list if you like. Lists are mutable, which means that you can change a list at any time by adding, removing or changing objects. Python's list is an example of mutable data structure in that it can change or mutate at runtime. You can grow or shrink a list by adding and removing objects as you needed. It is also possible to change any object stored at any slot. When an ordered like collection is immutable, that is, it cannot change, it is called a tuple, which is our third example C. So tuple is an ordered immutable collection of objects. A tuple can also be called as an immutable list. That means once you assign objects to a tuple, the tuple cannot be changed under any circumstances. It is often useful to think of a tuple as a constant list. Most new Python programmers scratch their heads in bemusement when they first encounter tuples, as it is hard to work out their purpose. After all, what is the use of a list that cannot change? It turns out that there are plenty of use cases where you will want to ensure that your objects cannot be changed by your or anyone else's code. We will return to tuples in our next session, and we will talk about them in more details as well as use them. Lists and tuples are great when you want to present data in an ordered way, such as a list of destinations on a travel itinerary, or a list of objects in a grocery, a list of objects to purchase in a grocery list or something like that. But sometimes the order in which you present the data isn't important. For instance, you might want to store some user details such as their ID and password, but you may not care in what order they are stored, just that they are. With data like this, an alternative to Python's list or tuple is needed. And there comes dictionary, our example number B. If you are keeping your data in a specific order isn't important to you, but structure is, Python comes with a choice of two unordered data structures, dictionary and sets. So a dictionary is an unordered set of key value pairs. Depending upon your programming background, you may already know what a dictionary is, but you may know it by another name, such as an associative array, a map, a symbol table, or hash. Like those other data structures in other languages, Python's dictionary allows you to store a collection of key value pairs. Each unique key has a value associated with it in the dictionary, and dictionary can have any number of pairs. The value associated with a key can be any object. So dictionaries are unordered and mutable. It can be useful to think of Python's dictionary as a two-column multi-row data structure. Like lists, dictionaries can grow and shrink on demand. Something to watch out for when using a dictionary is that you cannot rely on the internal ordering used by the interpreter. Specifically, the order in which you add key or value pairs to a dictionary is not maintained by the interpreter and has no meaning to Python. This can stump programmers when they first encounter it, so we are making you aware of it now, and when we meet it again in detail, you will get less of a shock. Rest assured, it is possible to display your dictionary data in a specific order if need be, and we will show you how to do it. Now, the fourth data structure here is a set. Now, the final built-in data structure, set, is great to have at hand when you don't want duplicates to be stored in your data structure, or you want to remove duplicates quickly from any other collection. And don't worry if you mention sets from high school or your 10th class, and you basically this set also does the same thing as your mathematical set in your 10th grade. So in Python, a set is a handy data structure for remembering a collection of related objects while ensuring none of them are duplicated. And it also lets you perform unions, intersections, and differences just like any mathematical set. Sets like lists and dictionaries can grow and shrink as needed. Like dictionaries, sets are also unordered. So you cannot make assumptions about the order of objects in a set. As with tuples and dictionaries, you'll get to see in action in our next session. The four built-in data structures are useful, but they don't cover every possible data need. However, they do cover a lot of them. It is the usual story with technology designed to be generally useful. About 80% of what you do is covered, while the other highly specific 20% requires you to do more work. So this is the case with Python also. These four data structures will cover 80% of your need. For the rest, highly specific 20%, you need to invent your own data structures. So without further ado, let's dive in a bit into lists. So when do you use lists? When you have a bunch of related objects and you need to put them somewhere in your code, think about lists. For example, imagine you have a month's worth of daily temperature readings. Storing these readings in a list make perfect sense. Whereas arrays tend to be homogeneous affairs in other programming languages, in that you have to have an array of only integers or only strings or some particular data type. Python's list is less restrictive. you can have a list of objects, and each object can be of a different type. In addition to being heterogeneous, lists are dynamic, so they can grow and shrink as needed. Watch this. So you can see the first two are of type string, the third is of type float, and the fourth and fifth are of type integer. All of them are stored in the same list E. So we can have heterogeneous a heterogeneous list. We can also append new values by just doing a dot append hexar, and then if you print a, you'll have this hexar appended at the end of the list. So a list can grow as shrink as needed. Lists are always enclosed in square brackets, and the objects contained within them are separated by comma. When a list is created where objects are assigned to a new list directly in your code, like this way, Python programmers refer to this as literal list, and in this the list is created and populated in one go. The other way to create and populate a list is to grow the list in the code, appending objects to the list as code execute, like this. We used comma instead of colons, so that was the error here. Okay, we still have something missing from this one. Okay, I think this one should work. Yeah. Sorry, my bad. I mistakenly interchange range with a list slice. We'll come to it later on what I was trying to do. So here we have this loop, and in this loop we have appended the value in the range slice, and we appended it to the list E. So as you can see, those values are here through E. Now if we do this again, and this time we use 3, let's see what's happening. So till this 9 part was appended before, and this 0369, this was appended in the second go. Now this is what I was trying to do at the time when we hit the error. Understand this. This range function starts from 0 till 10th, excluding 10th or excluding 10. So this much we knew earlier. Now this 3 here states that the step that it will take from one jump to another is should be of size 3. So it starts at 0, next stop is at 3, the next stop is at 6, and the next stop is at 9. At 9 it crosses the limit and it stops. So this is something that you need to keep in mind while using range, as it may be useful in your later programs. So this is how we can create a list on the go, either by creating it literally or by just appending it through a loop or any other piece of code. Now a list can also contain multiple lists, as we have already explained. A list is heterogeneous and it can store any type of data including lists. So let's create some program out of lists and see if we understand how to work with this. So let's do this. Let's create a list of vowels. VOW vowels is equal to A, E, I, O, U. Now let's define another word is equal to milliways. Now I want to check whether the letters in this word contain a vowel or not. So let's find out. For letter in a word, so this will iterate through every letter in the word, starting from M and ending with S. Now if the letter is in vowels, in that case I want to say, or I want just print the vowels, print letter. Let's see. Now here it says milliways is not defined. That's because I have not used the inverted commas with a string. A string should always be enclosed in inverted commas, otherwise it will treat it as a identifier, and we have not defined milliways as any identifier in this piece of code. So if you run this, now milliways is only two vowels and they are repeated 3 times. So we have 2 i's and 1 a, that is 1 I here, another I here, and the a here, and these are only vowels. So this is how we can use lists to work with our program. So let's use this as the basis of our working with lists and try to improve this as we go along. I know this is a stupid example, but stupid examples often teach you a lot more than the complicated ones. In order to learn a bit more about how lists work, let's take this code and extend it to display each found vowel only once. At this moment, the code displays each vowels more than once if the output if the word being searched contains more than one instance of that vowel. So we are going to be making a series of changes to this code. As a general rule, when the code we are experimenting on starts to run for more than a few lines, put it in a single block. Do not spread it across multiple slices or multiple cells, because these may sometimes be difficult for you to keep track, or sometimes for you difficult to understand. Now how can we keep track of the vowels that we have already found? Our current program displays each found vowel on screen, including any duplicates found. In order to list each unique vowel found and avoid displaying duplicates, we need to remember any unique vowel that we found before displaying them on screen. To do this, we need to use the second data structure. We can't use the existing vowels list because it exists, and let us quickly determine whether the letter we are currently processing is a vowel. We need a second list that starts out empty, and we are going to populate it at runtime with any vowels that we find. As we did it in our previous session, we will start with an empty list and we will keep growing it. So let's start with another empty list. So let's first copy this list that we have here. And then let's create a second list called second. How genius. And then let's update our code. So we have the word here as milliways. Let's copy this. Now let's start the loop. So for letter in word, if letter in vowels if letter not in font, we have font dot append letter. For vowel in font, okay. Okay, again found is not defined. Screw it. Why I'm using found here? Second. Okay, so as you can see, it's only displaying I once. Now what's happening here is, you know what this part of the loop already does. Now what's happening in this line is, it is searching if the letter is not in second, and if the letter is not in second, is appending the letter, and if the letter is already in second, so it has already been discovered, it does not append it. And at the end of it, only those which have been found uniquely once, they are only the ones which are printed. So this new code is pretty straightforward. Now let's make this a bit more interactive. Instead of using this word here, let's ask for the user for a word. So all we have to do is scrap out this line and put this part in. Now what this input function does is, it asks for the user of for an input, and what will it ask for an input is specified by the string given in this argument here. So let's run this. So it's asking for a word. Let me enter Mississippi. It has only I. Let's run this again. Sorry. Let's run this again. Let's say A gibberish, E gibberish, I gibberish, O gibberish, U gibberish, again U. And if we run this, we have all the 5 vowels A, E, I, O, U, because these are all in this hypothetical all vowels including word. Now lists in Python are just like arrays in other languages, and then some. The fact that lists can grow dynamically when more space is needed is a huge productivity boom. Like a lot of other things in Python, the interpreter takes care of the details for you. If the lists needs more memory, the interpreter dynamically allocates as much memory as needed. Likewise, when it shrinks, the interpreter dynamically reclaims the memory no longer needed by the list. Other methods exist to help you manipulate lists. Let's discuss some of the most useful methods. Now, let's create a list for our testing purpose here. So, we have this list and let's print this list. Now, let suppose I want to remove 4. So, all I can do is just number dot remove 4, and then if I print number, 4 is not here. So it takes a value, searches it in the list, and if it finds it, it deletes it. Now let's see what if the number is not present here. It will give an error of value error x not in the list. The remove method is great when you know the value of the object you want to remove, but often it is the case that you want to remove an object from a specific index slot. For this, Python provides the pop method. The pop method removes and returns an object from an existing list based on the object's index value. If you invoke pop without specifying an index value, the last object in the list is removed and returned, just like a stack if you have studied data structures in other languages. If you specify an index value, the object in that location is removed and returned. If the list is empty and you invoke pop with a non-existing index value, the interpreter raises an error. So let's try pop in this one. So this prints out 6 because that was the last number here, and if we print the list now, it will only have just 4 values. Now let's see if I want to remove this 2 value. So the index of this 2 value will be 1. So let's try this. Print, sorry, number dot pop one. So as you can see, 2 is removed and the list now only has 1, 3 and 5. Objects returned by pop can be assigned to a variable if you wish, in which case they are retained. However, if the popped object is not assigned to a variable, its memory is reclaimed and the object disappears. Now there is another method called extend, which takes a list of object and appends it at the end of the list. So we have the list 1, 3, 5. Now if we do this number dot extend, now this takes a list as an argument. So let's give it, okay, so these 1, 3, 5, these are odd numbers, let's give them even numbers, 0, 2, 4, and sorry, and then if you print this number list number, it will have these 3 values appended in the end. The extend method takes a second list and adds each of its object to an existing list. This method is very useful for combining 2 lists into a one. The append and extend method get a lot of use, but they are restricted to adding object onto the end of an existing list. Sometimes you will want to end, or you want to add things to the beginning, or you can also would like to add things at a particular index value. So there comes the method insert. It takes an index value in an object, and the insert method inserts an object into an existing file before a specified index value. So here suppose that we want to put something between 3 and 5. So the index of 5 is 0 1 2. So if you want to insert something before 5, we want to provide the index 2 here. So let's do this, number dot insert, and I want to insert the value of minus 95 in the index before the index 2. And if you print number, then sorry, it is not working. Oh, my bad, I mixed it up. So first comes the index value, and then comes the value which you want to insert. So as you can see, now minus 95 is inserted before the second index, 3 was the second index before that. We can use the insert method to insert objects anywhere in the list as long as you get the insertion index right. Now lists also support the square index notation, as you have very well know. So we can just find out that number 6 will give you 2, number 5 should give you 0, number 2 should give you minus 95. Yes, okay. So it also supports the square bracket notation. Now try this. I'm going to pause for 2 seconds. Think about what will happen in this code. Okay, let's run it. So here, as you can see, first we had this list without doing anything. So this was the list. Then we assign new number. We created a variable n number, and then we assigned the value of number into this, and then we called n number dot pop, and then we printed number, and then we printed n number. But both of these lists are the same exactly. Why? This is because when it comes to copying an existing list to another one, the assignment operator only works for the references, not for the exact value. So basically n number now are pointing at the same exact list. The problem is that in both the first and the second variable, that is the n number are pointing to the same data. So if you change one list, the other changes too. So how can you copy a data structure? If using the assignment operator isn't the way to copy one list to another, what is? To solve this problem, list comes with a copy method which does the right thing. Now just do this dot copy. Understand that this value has already been changed into this, so now both of these are currently containing this list, and if you execute this, it had this list first, and then we printed number, so this is number here, so number is the exact same thing as the other one, but new number has changed in size from 7 values to 5, sorry, to 6. This is how copy works. So as you have demonstrated earlier, Python supports square brackets, but try to understand this. This is the entire list. This is just a single integer. Try this. So it is starting from the beginning point, that it is starting from here, but is only going all the way towards the fourth index, 0 1 2 3 4, fourth index, while here it is 0 1 2 3 4 5. It has 6 elements, so it has till index 5. It has 5 elements, so it only has till index 4. But why? Number had 6 values as of this now. Turns out that the start, stop and step notation that we used in range also works in list also. So you have 3 values basically in this way, A, B and C, and if you give A the value of 0, B the value of 6 and C as the value of 2, this will show only this 3 lists. First it is showing 2 because it is starting at the 0th index, it is going all the way till the last index, that is 6, so it is going all the way till this point, but it is skipping 2 values at a time. So this is start, stop, step. This is called the slice or Python slices, and this is how you can work with them. Python also supports the negative index, and they are the same as going backwards. So if you do number 0, this will give you the first element. If you do number -1, this will give you the last element. Now in this case the first and the last element happens to be 2, so let's go for the second last element. It should give us 0, and let's go to the fourth last element, so this should give us 3. Yes. You can play with the slice notation as much as you want, and it is really helpful to get a hang of it. Another important thing to note is that this only gives you a copy of the list, not the actual list, so they are non-destructive. The list methods used by the above Jupyter notebook converts one string into another was destructive, as in the starting the insert, append and other operations, they change the list, but slicing a list is non-destructive, as extracting objects from existing list does not alter it, the original data remains intact. So that's another reason to use slices. Now as you know, the for loop is very good with lists. So if you do for I in numbers print I, if it, sorry, oh, I put numbers in the above. Let's go for numbers. So we do this by it also works for slices also. So if we start and go all the way but only to the second last element, we should not have 0 and 2 in the end. Yes. And if we go to the 0 last element skipping 2 steps at a time, it should have only 2, 95 and 5. Yes, 2 minus 95 and 5. So this is how you can play with lists. Now, when Python programmers find themselves in a situation where they need to store a collection of similar objects, using a list is often a natural choice. After all, we have used nothing but list in this example so far. In fact, lists are a great choice when you have a collection of related anything. But imagine if you need to store data about a person. So you need to store his name, you need to store his gender, you need to store his age and other kind of stuff. And lists are not great in that manner. Suppose if I feed my data in a list, it will be underscore. Now if I want to find out my first name, I have to go do this 1, oh sorry, 0, this gives me my first name. If I do 1, this gives me my second name. But there is an easier way. We can just use a dictionary here. So instead of doing this, we can just copy this and paste it here. Then we can give this first thing is that we need to remove the square brackets, sorry, and then we need to give these names. So we have first name is Shubham, MNA, middle name is Kumar, last name is Singh, age is 26, address is Mehdipatnam. If we do this, so all I need to do to find any details is Shubham details, and I have to give the key. So if I want to find my middle name, I just have to give middle name and it will give me this. Now this is a Python dictionary, and we are going to learn more about this in our next session will be on structured data.